Well, hey everybody, welcome to this video. In this video I'm going to go over this uh, heater install and the concepts of what I'm going to be doing with it. If you haven't subscribed, please consider subscribing and hit the like button. Let's get this out there. I'm trying to build my channel back. So if you want to see more on this, how I'm going to end up setting all this up in here, and later down the road the greenhouse build next year starting, go ahead and subscribe, hit the little notification bell, hit the like bell. Much appreciated. Now let's get on to this video. All right, everybody, I'm going to go over just a little bit on this Chinese diesel heater that I purchased to put in my greenhouse. The concept here is, at this time, is not to keep the greenhouse extremely warm all the time. This is a greenhouse here that we're going to be tearing down and then rebuilding a longer one, because some of the upper boards are starting to rot. When I built this, I didn't use treated lumber, and it sat for about 5 years with no covering at all on it because of my heart failure. I didn't have time to mess with it. So we're going to be rebuilding one. We're going to be building one about 2 feet wider and several feet longer. This is 8 by 16 feet. We're going to be building one 10 by 24 is what my wife wants. Currently, right now, what we're doing with this is we're trying to just keep the greenhouse from getting down into a deep freeze. I'm experimenting with some tomato plants here that are cold-natured. They don't seem to be bothered as much by cold. You can see that they're still flowering. I do have some tomatoes on some. Hopefully you can see down there. I'm not sure. And it's been down at least one time below freezing in here. But the whole idea of this is I want to keep it to where it doesn't go below 40. Now, unfortunately, the diesel heaters do not, even though they have a thermostat mode, in other words, they can control to a certain temperature, they don't ever shut off. If they get to the temperature that you have set, what they do is they slow down and they throttle down. They just go into an idle, but they're still running. They're still burning fuel. They never go into a shutdown. Now, you can buy a aftermarket controller thing called an afterburner. Currently, right now, here in the United States, to get one here with some other stuff, you're probably looking at about like $108. I only paid $118 for this whole unit here. Now, I'm going to say something. This is an 8 kilowatt. There's a lot of people out there say that there's no such thing as an 8 kilowatt. That may or may not be true. Nobody has ever actually proved one way or another by actually doing a wet bulb test that you need to do to be able to calculate BTU. So that's an ongoing argument, and I'm not going to get into an argument. I bought the 8 kilowatt for 2 reasons. Possibility it could be more than a 5 kilowatt. Second reason is it was cheaper than a 5 kilowatt, and it came with, even though it said it was a 10 liter gas tank, it came with a 15 liter. So I got a bigger fuel tank, and at least a 5, as a lot of people are arguing, if not over a 5K unit. Now, they list these in kilowatts instead of BTUs. I don't know why. But that's the way it is. Okay, I think they'll hold me to this. I'll pop it up on the screen. I think 8 kilowatts is something like 27,000 something BTU. Where 5 is down quite a bit below that. I'll pop both those up in there. But anyway, get back to this. So I installed it in here. This is temporary. I just built this little shelf. The exhaust and stuff is going down underneath. Excuse the mess under here. But there you can see the exhaust, the fuel pump. There's the air intake and stuff. You'll also notice that I'm using the green hose that everybody says, oh, no, you can't use that. Well, they say because it's soft, it flexes and this, and the pump pumps, and it'll flex open so you won't get as much of it. I'm telling you, people, for one thing, there's no pressure up there when it comes out. So there's nothing to pressurize the tube with. And the tube, while being soft to some degree, is not soft enough that that little pump could ever expand that tubing. And also, this is a temporary installation until I build a new greenhouse. So I don't really care. I may change it to the other type of fuel line later, mainly because it's easier to put on and off. That'd be the only thing. I'll also show you the other thing. You see it goes through the wall there, behind there. That's going through what's called a through-hole fitting, 24 millimeter here, and it comes out right there. And so there's no need to put all that fire stuff on there. Okay, so let's stop this for a minute. Now let's get into the concepts here. What I'm going to do is I'm going to hack either the controller or the remote key fob to where I can put a control on here that will actually turn the heater on and off based on whatever temperatures I set. Now the heater does have to go through cool down when you shut it off, so it's not like you turn it off and it's instantly off. It goes through cool down. Also, when you go to tell it to start up, it has to go through a startup procedures. All that takes a little time. So even though you're going to be doing this, it's not going to be instant. The main thing is I don't want it sitting here idling all the time. I want it to shut off after it reads as a specific temperature. Right now, I'm considering come on at 40, turn off at 45. That's Fahrenheit. And in another video, I'm going to go over how I'm going to start setting up the controllers. But I have two ways. This is a 3 button. Now this thing here is semi-defective because it never gets any brighter than that right there. And you can't read it. I've contacted Vivor about that, and I'll see what they say. But what you want to do, no matter which controller you have, if you're going to try to do this, you're gonna hack it. On this one, it's got one button, on, off, and you'll hold it for a certain amount of time to do one thing and a certain amount of time to do another thing. The key fob has an actual on-off button right here, on and off. Now, there again, this thing being a little flaky, I don't know if it'll turn on or not. Let me see if I'm gonna hit the key fob. And best I can tell, it did not turn on. Yes, it did. So just a quick pulse of the on button told it to turn on. Okay? It's down in the real low blowing mode right now. It's in pre-startup mode. Okay? My charger kicked on because it's starting to pull power on the glow plug. And it's trying to draw the battery down. The battery, you don't ever want to go with just a power supply only. You'll see a lot of people set these up where they only have a power supply, no battery. You don't want to do that. If you lose power that's supplying the 120 volt or 240 volt, depending on where you live, power to your power supply, your 12-volt power supply, if that goes off, everything shuts down in the heater. It doesn't go into cool down mode, and it will actually destroy your heater. It'll melt the casing and everything else. So even if you use a power supply on it, you want a battery as a backup on there. So if you go through a power blip, it will at least have power to keep running. If the battery power gets too low, it will signal it to automatically go through a shutdown. So anyway, like I'm saying, what we do here is if I hack the key fob, I want to be able to mimic the pushing of the on button to tell it to come on. And by the same token, I want to be able to mimic pushing of the off button to tell it to go off. Now, in this case, I would need a set of contacts to close for just about a second or two to signal on, and I think it's about the same thing to signal off. We're going to try that in a second here and see what it does. So I would be a set of wires soldered across the button contacts in here, a set of wires across here, and going off to a control. Now what we're going to use is what's called a time delay relay. You can get all kinds out there. You can get little ones. I'll throw some images up. You can get little ones that are just like a relay on a circuit board with a little trimmer you turn to adjust the time. You can get them to where it goes to the display and you can program them. I'm going to use the ones that you can program, mainly because I have some right now. I think they're 24 volt. I'm going to double check that, but they cost the same to buy them as it does the other ones. And so if I have to buy 12 volt ones, I'll do that. What I'll probably do to start with is I've got another power supply that I can power 24 volts to those controls. The thermostat that I'm going to be using to turn them on and off is called a PID controller, temperature controller. And the one I've got is, I wanted one that ran on 12 volts. It only displays in centigrade. I didn't want to spend a lot of money, so I bought a cheap one. It only displays in centigrade. And you can set the temperature and then you set a differential. So it's like you say, I want it to go on at 40, so I set it for 45, and the differential is 4 degrees Celsius, so it's, I think, 7 degrees Celsius to 4 degrees Celsius, something like that, with the differential. I'll go over that, all of that in the controls video, that when I do the controls and actually building the controls. But the concept is we're going to use a time delay relay, and when it's signaled by that temperature controller, it's going to put out a couple of second pulse. If I do it to here, it'll be to this on button to turn it on. Then I need to signal it again to turn it off. Now, if I can just do the same on this, the controller I have can provide a temporary time signal when it's told that it's on, and it can then time out, and then it waits, and as long as that signal is there saying you've been signaled, it just did that one time out, that's the end of it. When that signal's removed from it, in other words, the temperature controller says turn off, the signal to it is removed, then it will go through another timing sequence, and I can have it do the same thing here. But that would only work if I was on this single button. On here, I don't think it will work. I would have to have two, and I may have to have two there, so one for on, one for off. Now, the controller I have only has a single pole open contact for both heating and cooling. So if I wanted to use the heating only to control two timers, I would have to have it power a double pole relay, a single pole double throw relay, to be able to do that. It also has a cool deal, but it has what's called a compressor delay. And the compressor delay defaults 3 minutes. You can run it down to 1. So that's an option. I can say, once you reach 7 degrees C, which is 40 whatever, turn the heat off and wait 1 minute, and then turn the cool on, and I can live with that 1 minute delay. So you're going to see how all that goes on there. So right now the heater's heating, it's going, it's putting out good hot air. I'm going to tell it to turn off, and we'll see if it goes into the, like I said, you cannot read this thing. Now that did not turn off. So we'll push it and hold it. A couple of seconds to tell it to turn off. So I can hack the bob, or I can hack the remote. To do that, I'll have to open it up and solder across those buttons, across that button, so that I can emulate that being closed for a certain amount of time. And that's probably how I'll do it. Is I'll emulate this and tie into this, and not mess with the key bob. At least that's what I'm thinking. Now, like I said, this particular display, it's got a defect in it that it doesn't ever get bright enough to see, for whatever reason. If it's at night, you can see it. If it's totally dark out here, you can see it. But during the day, as you can see, you can't see nothing on it. So I have put in a ticket to Vevar about that, and I'll see. I mean, if it does, it does. If it doesn't, it doesn't. You know, I can always get another one later or whatever else. Now, the thing of it is this will pop out of there. So you can mount this plate, and then this pops on. Now, my idea is to use this box right here as a control box. So this would mount. Now, it's shut down 2 degrees in a low blow mode. Is to mount that in that box right there. And then I'll have my temperature settings and my time delays up there. Probably going to have an indoor out temperature, and I'll probably put a current draw meter all in within this box. And that'll be my control box. So we can go over that design there. But this video here is just to show you the basic setup I've got. I've got it here. I did this. One thing I did notice, it did not take very long at all for this thing to prime. Right now I've got just regular diesel in here. I'm later going to be purchasing red dyed diesel, which I need to use in my tractor anyway because it's cheaper. Before I'd ever bothered with it because it wasn't that much bad, but you know, price everything up now. So anyway, this is going to go set down. Now I do have a freezing, I think it's going to be down below around 31 to 30 tonight. And like I said, I don't want it to freeze too long in here and maybe freeze my tomato that's actually hanging on there. So I'm probably going to come out here and turn this into a real low mode. It's going to be constantly on low mode. And I'll just have it run at about 1 hertz or whatever it is the lowest setting that I can go on. I just have to figure it out. Like I said, you can't see it. Have to be in the dark to read the thing. And so I have to come out here at nighttime to read it. Right now, currently, I've just got a battery charger in here. I tried with this little one. This little one just didn't have enough wamp on it to overcome what was going on when this was running. So I put my Stanley on here. I'll probably later just go ahead and buy a 12-volt power supply that's capable of about 30 amps or something and put it on here, tie it into the battery, tie everything into the battery. So I've got the power supply that's constantly powering everything. It's not like a charger per se, but we'll see how that goes. It won't put out too much to overcharge the battery. You know, because as long as I don't push the battery over 14 volts, it's not going to overcharge the battery, regardless of whether the power supply goes into a trickle mode or not. Anyway, that's basically what we're doing here. This is just a kind of overview video of what we're doing. And I put the fuel tank inside. A lot of people go, why you got the fuel tank inside? Well, because you put the fuel tank outside, it's not so bad in the area that I'm in, where some, you know, a lot of times it only gets down to maybe 28, 26, and that's rare. But a lot of areas it would be, you don't want the diesel out where it'll gel. If you got it out where it get real cold, maybe gel and whatever else, you're going to have to put additives in it. In here, I'm not worried about it. I'll just come in. It's on the door swing side. I can open up and fill it right now. I've got the tank about half full, and I've got some more diesel down here that I can put in there. So anyway, that's basically it on this one. This is a Vevor. I'll give a link to it on the website. It shows for $169 something. But if you register with your email address where you can log in, it goes down. It was going down to like $119 whatever, and so it was about the same price as a 5K, right around that. It's cheaper than some of them that were 5K, so that's what I decided to do, was just use these. Anyway, that's it. See you in the next one.